We're going to take a look at bones and skeletal tissue. But before we get to bones and skeletal tissue, let's review skeletal cartilages. The human skeleton initially consists of just cartilage. It is eventually replaced by bone, except in a couple of areas that require flexibility. Now, there are a few cartilages that remain in adults after ossification, and again, that's where flexibility is needed. Some examples are the ear, nose, and throat. But also, let's review general cartilage structure, not just the fact that cartilage provides both strength and flexibility. Well, cartilage tissue is molded to fit its location and function. It consists of primarily water that accounts for its strength and its resilience. It's not innervated and it's avascular. So the tissue that we call cartilage does not have nerves or blood vessels go into it. Thankfully, cartilage is surrounded by dense irregular connective tissue called the perichondrium. This contains blood vessels, which allow for nutrient delivery via diffusion to cartilage cells. The perichondrium also acts as a girdle, kind of this outside layer around cartilage tissue that helps cartilage resist outward expansion. And cartilage is made up of chondrocytes. And so these cells, even though they're not the predominant part of cartilage, which is the extracellular matrix, they still need nutrition, and they're going to be housed in areas that can receive this nutrition called lacunae. These are essentially small cavities, and they are surrounded by the jelly-like extracellular matrix of cartilage. So here's a general look at the association of the perichondrium to the chondrocytes that are in their lacunae for kind of the base structure of cartilage. Here we're looking at some of the respiratory cartilages, such as those from your larynx and your trachea, parts of the upper respiratory system. Keep in mind there's more than one type of cartilage: hyaline, elastic, fibrocartilage, and they all have the same basic components. They have cartilage cells or chondrocytes encased in small cavities called lacunae. They're mostly extracellular matrix, just like all types of connective tissue. And that extracellular matrix consists of ground substance and fibers. And collagen fibers are going to be abundant throughout all different types of cartilage. Now, in some types, we might see elastic fibers and other types of collagenous fibers, but we're going to see collagen predominate. Speaking of predominating, let's start with the most abundant type of cartilage, hyaline cartilage. It looks like frosted glass, provides support, flexibility, strength, resilience, and it is made up of fine collagen fibers. And they're hard to focus on. So if you look at hyaline cartilage through a compound light microscope, it really appears kind of like frosted glass. You can find hyaline cartilage all over the body. It's the forerunner of long bones and embryo. It makes up parts of the nose, the respiratory system, the ribs that connect to the sternum, and it also is found at the ends of long bones. So if you wanted kind of a general area to find hyaline cartilage, you could say the axis of the body. Here we're seeing a view of the costal cartilages, which are cartilages made up of hyaline cartilage that connect the ribs to the sternum. Of course, we have hyaline in many other different locations, but this amorphous matrix of collagen fibers is a very supportive network. And not only does it contain chondrocytes and lacunae, it supports and reinforces and has cushioning properties and is able to resist compressive stress. So it's going to be really helpful as a strengthening agent in flexible areas of the body. We can't forget there's other types of cartilage. While hyaline cartilage is the most abundant, elastic cartilage is definitely resilient. It's able to, with its elastic fibers, bend and then go back to its original shape. Areas where you could find elastic cartilage are the external ear, also known as the pinna, and the epiglottis, which is a flap of elastic tissue that closes to essentially protect the trachea and prevent food from going into the trachea when you swallow. Now, again, the key thing about elastic cartilage is all those elastic fibers in that extracellular matrix between the lacunae that house chondrocytes. This is going to give that cartilage a lot of kind of resilience in bending, but being able to go back to its original shape. And then fibrocartilage is by far the most highly compressible and has the most tensile strength of any of the other types of cartilages. So it's found in areas that are subjected to essentially the most pressure and stretch, but still areas that are going to rely on flexibility. It contains very thick collagen fibers, and it can be found in areas like the meniscus of the knee, so that's between the femur and the tibia, intervertebral disc between your vertebrae, and at the anterior aspect of the pubic bones, or an area called the pubic symphysis, where we have an anterior connection of those hip bones. So those are just some examples of where we combine fibrocartilage. You can see in this image, it is very fibrous. We can see those collagen fibers. And we can also see an area where it's located. This is an anterior view of the right knee in this slide. And we can see that the femur up top meets the tibia down at the bottom. And there's this padding in between those two bones. And that padding is primarily made up of fibrocartilage. So what if we just need to come back and look at the general locations for cartilage? This is a great slide to utilize to do so. You can see the general locations of hyaline, elastic, and fibrocartilage. Keep in mind there's similarities between all these cartilage types, including that they contain chondrocytes, which are in cup-like structures called lacunae, and they are made up mostly of extracellular matrix, a kind of a gel-like ground substance, with collagenous fibers. And if you're more of a text person, here is another review slide just telling you about those three types of cartilage, what they do and where they're located, and some general information about their strength, flexibility, and resilience. We also want to talk about the growth of cartilage because it is a flexible matrix. It's a great tissue to lay down essentially as the basis for the embryonic skeleton because it's maneuverable, it can bend. Eventually, it will ossify and turn into skeletal growth. And so, for that reason, because most bone has a cartilage model before it turns into bone, cartilage growth is going to match skeletal growth. And cartilage grows in two ways: appositional growth and interstitial growth. Appositional growth is where we have cartilage forming cells in the perichondrium, so on the outside of the cartilage model, secreting matrix against that external surface of already existing cartilage. So it's essentially new matrix being laid down on the surface of the cartilage between that cartilage model that already exists and the perichondrium. Whereas interstitial growth is growth from within, where chondrocytes within the lacunae, within those cup-like structures, divide and secrete new matrix. That expands the cartilage from an internal space. So we're making new matrix made within cartilage with interstitial growth. Now this chart is going to be a great way to essentially memorize or kind of compare and contrast oppositional and interstitial growth. Oppositional growth is growth from the outside, and we're going to see this cause mainly an increase in width for cartilage. And as this type of growth continues in bone, it also can cause an increase in width in bone. For interstitial growth, this is growth from within, and it's going to be from within the lacunae. So this increases in length of the cartilage model. And when bone grows similarly, bone grows in length. Now keep in mind we're talking about cartilage, but skeletal growth is similar. And we see that the calcification of cartilage can occur during normal bone growth in youth, and we can start to see kind of a lack of this cartilage growth in areas that should remain flexible. And we see this calcification or abnormal bone formation, I should say, occur more in old age as hardened cartilage forms, and that's definitely not the same as bone. It's kind of an abnormal condition of hardening. All right, to continue on, let's start to do some classification. We're going to be looking next at the 206 named bones in the human body, or at least in general, and we'll start by classifying them into two large groups, the axial and appendicular skeleton. So that's what's going to be in the next video, so make sure to come back and take a look.